Good morning, Otters. Welcome to Friday. Hope you all had a really good week and you've been getting on okay with all of your home learning. Any problems, just let me know. So, yesterday we finished our snick for tea and I told you we were going to be reading a new book, that it was non-fiction and it was quite funny. So, we are going to be reading Why is Snot Green? And other extremely important questions and answers from the Science Museum. So the blurb says, why is snot green? Do spiders have ears? Do rabbits fart? How big is space? Find out the answers to these and an awful lot of other brilliant questions in this funny and informative book. So I thought, for a bit of a change, we would do non-fiction and hopefully find out some weird and wonderful facts to keep us entertained and informed in these strange times. So, I'm going to read the introduction because it's quite funny. Introduction. This is a book about science, and it's a book about answers. The answers to so many of those crazy questions you may have once thought about, but then never got around to asking. And that's what science is all about. Unanswered questions. Too often, people are put off reading about science because they think it's too hard to understand or just too boring to bother with. Besides, they say, science doesn't have all the answers. They're right, it doesn't. But it does, I think, have some of the very best questions. What is space made of? Do spiders have ears? What do people taste like to sharks and tigers? Will evil robots take over the world one day? At the Science Museum, children and adults ask us questions like these every day. If we know, we'll try to answer or help people to figure it out for themselves. Yet, very often the answer just leads to another question. But why is that, they say? How do you know that? Is another favourite. This leads to more explanations and even more questions. And that's how science works. We keep asking questions. The main reason why science is such a useful way of thinking about things is that we're never happy just to say, I don't know, and leave it at that. If we don't know, we want to know, and we'll keep on asking questions until we find out. So if you think science is too hard or too boring, you've just been asking the wrong questions. Now let's have some fun with some of the good ones. So the first section is called Lost in Space. The universe can be a pretty dizzying place. It was born in an almighty explosion of energy. It's so massively, hugely, immensely enormous that it's almost impossible to imagine how big it really is. Within it, there are spinning planets, burning suns, icy comets, and vast clouds of floating dust and rock. Planets, moons, and asteroids whip around each other like cosmic dance partners. Stars are born, stars die, and stars collapse into mysterious black holes in space. But why did it turn out that way? Where is it all headed? Are we all alone in it? And come on, how big could it really be? Want to find out? Then read on. So each page has a key question and then the answers to it. So, how big is the universe? Big, proper big, crazy big, billions of times bigger than the biggest thing you can imagine. I don't know about that. I can imagine some pretty big stuff. Okay, let's give it a go. Let's imagine the size of the universe. Probably best to start small and work up. So let's start with something fairly big, the Earth. The Earth is about 8,000 miles wide. If you drove a tunnelling car straight through the middle, you'd get to the other side in about 5.5 days, going non-stop at an average motorway speed at 60 miles per hour. There's a little asterisk and a little star here. It says, you can't, of course. C, could you dig your way through the Earth to Australia, page 54, if you're not sure why. But imagining this will help us get our heads around even bigger scales. 5.5 days? 8,000 miles? Doesn't sound so far. Right, it's not. So let's try a longer journey. Say from here to the moon. The moon doesn't go around us in perfect circles. It gets closer and further away from us at different times of the month. But on average, it's about 240,000 miles away. It would take about 168 days to get there in a 60 mile per hour flying space car. Even with rocket propulsion, the Apollo astronauts took about 3 days to get there, and it was a real squash in their spacecraft. Similarly, the journey from Earth to the Sun is about 93 million miles, so it would take about 176 years by space car. To get right across our galaxy, the Milky Way, it would take about 1 million billion years. To make the journey of 621 million billion miles. So, what does that tell us? That a space car would be cool, but at 6 miles per hour, it'd be pretty rubbish for getting about the place? Yes, quite. That, and that the galaxy is pretty huge in itself, let alone the universe. I'm running out of space to put all the zeros after the numbers here. Alright, what if you had a space car that could go at the speed of light? Now we're talking. The speed of light is about 670 million miles per hour. So a car that fast could do about 6,000 billion miles, or 6 trillion miles, if it kept driving non-stop for a whole year. We call this distance a light year, and it's much more useful for measuring the huge distances between stars and across galaxies that we've been talking about. For example, the Milky Way is about 100,000 light years across, so it would take 100,000 years for our souped up, super fast light speed car to cross it. Still way too long to manage, but easier to imagine maybe. Go on then. How big is the whole universe? Well, we can only measure the universe as far as we can see it, with the best telescope we have. That's about 15 billion light years, or 90 billion trillion miles. I won't even bother trying to write that out with the zeros, in every direction. So at the speed of light, it would take at least 30 billion years to cross it. That's about 16 billion years longer than the age of the universe itself. So big then. Like I said, crazy big. And that's just the bit we can see. Beyond that, we know it extends even further because the light from the stuff we can see at the edge has taken 14 billion years to reach us, and the universe has expanded quite a bit since then. It might even curve back on itself, like the sea does as you sail around the globe. If that was the case, you could circle the universe and end up back where you started from. Now that would be cool. Yes, it would. But all your friends would be many, many billions of years older, so even if they were still around, they probably wouldn't know what cool was anymore. So, the next one is, what is space made of? Well, it's not just nothing. Space is, at the very least, filled with gases spread out very, very thinly. It also bends and possibly rips, so it must be made of something. But space is, well, space, isn't it? No air, no gravity? Well, not exactly. Gravity is actually everywhere in space. Its pull becomes weaker the further you move away from one particular source, like a planet, but it's still there. And while it is true that there's no air in space, there are other things spread around it. It's only because the stuff is spread out so thin, and space is so big that we can't detect it very easily. So what is this stuff? Mostly hydrogen and interstellar dust left over from the Big Bang. How much of it is out there? Well, there's billions of tons of it, but it spreads so far and wide across the universe that you won't find more than 1 atom per cubic centimetre of space in most places. You've probably been told that gases spread out to fill their containers, right? Well, if there's nothing else in the container, then they do. In this case, the container, the universe, was empty and is now at least 180 billion trillion miles wide. Spread over this distance, even billions of tons of material can look like virtually nothing. It just depends on how hard you're looking for it. It's a bit like Marmite on toast. Spread it thinly enough and only the real Marmite haters will detect it. You can try that one for yourself. Okay, so rather than say there's nothing in space, you could say there's almost nothing in space instead. Exactly. That will not only be more accurate, but it will also freak people out, which is always fun. Then we've got top 10 things to do in space. 1. Float. 2. Drift. 3. Hover. 4. Do somersaults. 5. Spill some milk and catch it again. 6. Play zero gravity football. 7. Try to hit the moon with a frisbee. 8. Draw a halo above your head with toothpaste. 9. Wonder where your spaceship went. 10. Panic. Any of you got any good ideas about things you could do in space? Let me know. Okay, we are going to leave it for today. I hope you enjoyed that. It's something a little bit different. I certainly enjoyed it, and I know that it gets quite funny when we get into the animal answers and being human sections. It starts talking more about bodily functions. So, hope you have a fantastic day. Today's Friday, so remember to send me your learning logs. I love to see all the things you've been doing. And stay safe and healthy, and I'll see you on Monday. No, I won't. It's Easter holidays. I will see you after the Easter holidays. Have a wonderful time. Keep washing your hands and stay inside. Bye-bye.